To be useful, a ray tracer needs to be able to extract data and allow the user to treat it outside or visualize it. To demonstrate this, I have a simple scene that contains a point source, a lens of glass, and a rectangle that will serve as a sensor. Now, if I trace this, we can see the path of the rays that are hitting the plane here. Now, this rectangle is not yet a sensor. To make it a sensor, one needs to go to its properties, click on the Sensor tab, and select first what one wants to record and the type of sensor one wishes it to be. There are two types. The first is the absorbing type. If I select this and I trace again, the rays hit the rectangle, they are recorded, but they don't go through, they stop at the interface. The second type of sensor is the transparent sensor. In this case, the rays are allowed to go through and interact with the objects that are behind this sensor. Now, to get the relevant file, one first needs to define in which directory this will be outputted. So once one selects the output directory and traces the simulation, there is a file that is related to the name of the object that will have appeared, that we can see over here. When one looks at this file, it contains some information relevant to the software and all the data of the rays that have hit the sensor. Okay, now Aether provides a simple analysis tool, which is here, in which one can load this sensor file, and we get the distribution of the rays onto the corresponding surface. Since it's wavelength resolved, one can define for which wavelengths one wants to filter the sensor. So in this case, I have not used a polychromatic source, so I'm going to change this to be polychromatic. And I'm going to trace this again, and this time the sensor contains polychromatic data that we can see the wavelengths here changes for each line. And when I'm loaded, it now contains polychromatic data, and I can, if I want to, filter the wavelengths that I want to display. So, of course, there are only a few ways in this computation, but this still works. So, on this figure, we can see the full ray distribution onto the face, so either as a heat count or as a parameter. We can change the type of gradient that it is displayed at. We can change the resolution, so when this window loads the sensor data, it does ray counting based on this resolution. So if I set it to something smaller, we basically have an histogram that is very, very coarse, and if I set it to something very large, we are going to start seeing the individual rays that have hit the surface.